Hey, this is lesson 9 of Unit 2 Topic 1, and this lesson is also about functions. So we're going to be looking at more key features of functions. That's what this lesson is really about. So finding key features of functions, which means like increasing, decreasing intervals. And it starts off with a warm-up, which is about something you haven't done yet, which is called a system of equations. It's called a system of equations because it's two different equations. We have two functions here. We've got 2x minus 7 and negative 4x plus 5. So what we're trying to do is find when is f of x equal g of x. If they're equal, that means that those two lines have intersected. So that's what I'm going to do. 2x minus 7, I'm going to graph it. It starts at negative 7 and it increases by 2. So this is called the y-intercept. The y-intercept is always the number by itself in a linear equation. 1, 2, 3, 4, 5, 6, 7. Okay, that doesn't really fit on the graph. And then it's going to increase by 2. Whatever's being multiplied by x is how much is either increasing or decreasing. It's increasing because it's positive. 1, 2, 1, 2, 1, 2. All right, I think I've got enough in order to make a line, and there's f of x. Now let's do the same for g of x. It starts at 5. 1, 2, 3, 4, 5. This time it decreases by 4. 1, 2, 3, 4. For every 1, 1, 2, 3, 4. There we go. There's the point. So it looks like the answer is at 2, negative 3. 2, negative 3 is the point in which they are exactly the same. So if x is 2 and the answer is negative 3, both equations satisfy that. Both equations. So that's basically what it's saying. If I plug 2 into this function, the answer is going to be negative 3. If I put 2 into this function for x, the answer is also going to be negative 3. That is the only place where the two functions are going to be exactly the same. So looking at this one, the y-intercept is negative 2, so that means that's the starting point, and it's decreasing by 5 each time. 1, 2, 3, 4, 5 doesn't really fit. I can also do the opposite. If I go backwards, 1, 2, 3, 4, 5, because that means the next one is 5 below. Perfect. Hopefully the answer is going to be one of those 2 points I graphed. This one starts at 1, and it decreases by 2 each time. 1, 2. Or you can say it increases by 2 if you go backwards, and boom, there's the answer right there. So the answer in this case is negative 1, 3. So what that is saying, if I take negative 1, plug it in for x, the answer should be negative 3. If I put negative 1 here, it's also going to have an answer of negative 3. All right, so this one is x. So there is no y-intercept, which means it crosses at 0. And there also is no number in front of the x. There's no coefficient. Anytime there's no coefficient, you've probably been told before that the coefficient is 1. So which means the next number is going to be 1 above the previous. It's going to look something like that. That's f of x. All right, so then I'm going to graph g of x. It starts at negative 3. 1, 2, 3. And this time it's going down 1. So it's going down like this. Boom, 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 boom. There's the answer right there. And the answer looks like to be negative 2, negative 2. If you put negative 2 in for x, no matter which function you put it into, the answer will always be negative 2. Well, this one's easy. Negative 2 is negative 2. All right, great. So there's the warm-up. And so this is all about finding domains of the range. This is what we call the key features of a graph. The key features are everything that tells you about what a function is. So the domain in this case, this is a discrete because it looks like it's a table. Alonso created a table of values by measuring the depth of the water every 10 minutes. So he's only collecting the depth every 10 minutes. We don't know what it's going to be in between because I guess the pool could be anything in between. So the domain is simply going to be a list of all those numbers. 0, 10, 20, 30, dot, 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 all the way to 120. Range in this case is going to be 4, 6, 8, 10. Now, 6 I've already used. 5, 4 I've already used, 5 I've already used, 7, 12, 9, 6.5, and 5 I think I already used. Yes, I did. There it is. Okay, so those are all the possible y's. Increasing interval, when is the function increasing? It looks like it's going up here. It goes from 4 to 6, up to 8, up to 10. So it's increasing from 4 to 10. So that means it's increasing from 0 to 30. Now, there is another way of writing it, but I'm not going to do that actually right now. I'm just going to keep it the way we've been doing it. The other way you could have done it is 0 to 30, but I actually prefer you not to do it that method. They'll teach you that in Algebra 2. I would like it, just keep it with the compound inequalities. The more we practice compound inequalities, the easier it's going to end up being in the results in the end. So then it decreases, 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 but then it starts increasing again, up, up. It goes up, 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 till here. So it also increases from 60, well, I almost wrote 4, from 60 to 90. It stops increasing at 90 minutes. And then it decreases. Perfect. So those are the two increasing intervals. The decreasing intervals, well, it decreases from here to here, so that's 30 to 60. And it also decreases from here to the end, from 90 to 120. All right, maximum, minimum. Maximum just means the highest. So we're talking about range if we're talking about height. So it looks like 12 is the maximum, and the minimum, 4, I believe, is the minimum depth. That's not very deep. All right, key features. Using the graph to describe the key features of this graph. So the domain of this graph would be 0 is less than or equal to x. It's continuous, and it looks like it stops right here at 120. The range of this function has a lowest of 0 and it has a highest point of 2, 4, 6, 8, 10, 12, 14, 16,000. And did they tell us what to use? No, it didn't. So I'm just going to call this f of x is less than or equal to 10, 12, 14, 16,000. Okay, increasing intervals. When is it increasing? I believe it's increasing the entire time. It's increasing the entire time. So that would be from 0 is less than or equal to x, which is less than or equal to 120. When is it decreasing? Never. What is the maximum? 16,000. And what is the minimum? 0. Minimum just means the lowest height. Maximum just means the highest height. All right. Next thing we're going to do, the water of the depth increases. We're going to either agree or disagree. The water of the depth increases and decreases throughout the 120 minutes. I disagree because it never decreased. The distance traveled is always increasing. I would agree with that. The distance traveled is a function of time. I would have to agree with that because it's definitely a function if you pass the vertical line test. The distance traveled is the greatest during the last 10 minutes of the trip. The distance traveled is the greatest during the last 10 minutes of the trip. I would have to agree with that because the distance traveled of the trip then during any other 10-minute interval. Okay, I would have to disagree with that because I think it's pretty constant the entire time. Does it really go up the most right here in the last 10 minutes? No, I'd have to disagree with that. It does not go up the most in those last 10 minutes. In fact, it starts to level off. It doesn't go up very fast. The domain of the domain of the distance per time graph is all real numbers. Let's see, that would need an arrow right here, so no. And there's no such thing as negative time. So that is a disagree. No way. The y-intercept of the depth of water over time is 0, 0. I would agree. That's where it starts. That's where it was on the origin to begin with. After 0 seconds, they've gone 0 distance. The distance traveled increases and decreases over time. That's disagree. That's very similar to the question up there. The water level is a function of time. The height of the water is a function of time. I would have to agree with that. This is a function. Depending on how long you've gone, will determine what the water's height is. The domain of the depth of the water with respect to time is 0, 120. The domain of the depth of time. Okay, so this is an acceptable way of writing it if you put it into brackets. So I'm going to agree with that. That is the domain from 0 to 120. I just don't want you to write it like that. I want you to use compound inequalities, because that's what's going to be expected of you on tests. The range of the depth of water over time is from 4 to 5. I disagree. The range of the depth of water, disagree. There's way more different heights than just 4 and 5. The distance per time graph has no maximum value. I disagree with that also. It had a maximum value of 16,000. The depth of the water reached a maximum at 30 minutes. No, it actually reached a maximum height at 120 minutes. Oh, wait. A maximum height. Ooh, I need to go back to the table. 30 minutes? No, 90 minutes. It took 90 minutes for it to reach its maximum height. All right. Homework. What is the explicit? So now we're starting to get into what's called explicit formulas and recursive formulas. A recursive formula just shows how the next term relates to the previous term, which is good that I showed you the warm-up, because the way I did the warm-up is really the answer to how do you find the recursive formula. It's actually very easy. The explicit formula is what we've been doing. So in this case, what is the zeroth term? Well, it looks like it's decreasing by 3. So if it goes backwards, this would have to be 8. So we know it started at 8, so we could say y equals 8 minus 3 per term. So it started at 8, that was the starting point, and it decreased 3 per term. The recursive formula in this case is going to be f of x. I need to give a starting point, not f of x. Let's go with f of 0 equals 8, and then f of any number, f of x, is equal to the previous term, f sub x minus 1, and then you're subtracting 3. So what it's basically saying is, if you want to find any number, all you got to do is take the previous number and subtract 3 from it. And you have to give a starting point because depending on what the starting point could give, a completely different set of numbers. The explicit this time, okay, so what are you noticing? I'm noticing that numbers are doubling. So if we go back to the 0th term, that would have to be 3. 3 times 2 times 2 times 2. So in this case, y is equal to starting point times rate to the power of x. It's exponential because it's multiply. This one was minus 3. Anytime it's an arithmetic sequence, it's linear. Anytime it's a geometric sequence, it's exponential. And the recursive formula this time, so we'll give a starting point. Let's say f of 0 is 3. That was a starting point. And f of any number would be the previous number, f sub x minus 1, the previous number, times 2. Done. The explicit this time. So what is happening here? It looks like this is an increase of 8. This is quadratic, it looks like. This is an increase of 4. Increase of 8, increase of 4. And you're noticing that the numbers, actually technically, I don't think this is enough information to determine it because we really need to make sure that the next number would have to be add 0. So the next number would have to be 4, negative 1. Assuming that that's true, the explicit formula would be the quadratic equation. Not sure if I really want to show you quadratics right this very second. What you should have noticed is that these numbers are increasing by 4. So the amount, no, it's decreasing by 4. What am I talking about? That is decreasing by 4. 8, it's plus 8 plus 4 plus 0. Then it's going to be plus negative 4, and then plus negative 8, and then plus negative. Okay, so that's the pattern. So what it has is what's called a double. It has a second difference. This is the difference of the numbers, and this is the second difference of the numbers. All right, so explicitly, if my memory serves me right, it's been a while since I've looked at these questions. Explicitly, it's going to have an x squared involved. Just trying to think of a better way of doing it. So the recursive, you use this. Use the linear fashion. So negative 4 times 0 plus 8. So it looks like it's negative 4 times the number is negative 8 plus 8. That doesn't work out, does it? Negative 4 times n would be 2. And then what would you have to do to 2 to make it plus 4? You'd have to add 2 to that. Negative 4 times 3 makes 12. Okay, I'll tell you what. We're just going to have to talk about this question in class when we get to it. If I don't get to this question when we get to do it in class, I'm just going to need some time to re-look at it because I know we're already at the 13-minute mark. My apologies. We'll definitely